Okay. So pollutions or emission standard is a command and control type of policy, of pollution reduction policy. So the government simply sets a level of emission or pollution deemed acceptable. So for example, we have the CAFE standard for automobile or automakers. All right. Now, in the most extreme case, the pollution standard will simply ban the production of the pollutant itself. In a controversial case in California is the use of methylene bromide. So methylene bromide, it is a fumigant, a pesticide, heavily used in California. Since the 90s, it has been banned in most countries in Europe and parts of Asia, but our California strawberry grower heavily relied on it. Right, so but eventually this was completely phased out because it was heavily toxic. Right, now so. CAFE standard. So just an example. So CAFE standard, right? The goal of CAFE standard is to reduce emission from automobile, and the way that the EPA decided to do that is to mandate a corporate average fuel economy. So every automaker has to meet a minimum average mile per gallon for all of the vehicle sold. Okay. Now this is so most. Emission standard are applied equally across the industry. So that means every firm is obligated to meet the same standard. Now, with the automobile industry, you can see pretty easily that this to meeting the standard is going to be very different for every automaker, right? You can take a car, compare, let's say, Honda and GM. Right? Honda makes mostly passenger small vehicles and mostly fuel efficient vehicles, and so it's going to be very easy for Honda to meet the fuel economy standard. Whereas GM, they make a lot of super duty trucks, heavy duty trucks, right? SUVs and such, and so it's going to be a lot harder for GM to meet that same standard. So there's pros and cons in these kind of emission standard. Another, just a brief history on the CAFE standard. Right? It started. It was motivated by the oil embargo in the late 70s. Right? And here the blue line here is the CAFE standard over time, and the industry has clearly kept up and even went beyond the actual fuel standard. The necessary CAFE standard. So, all right. Okay. All right. Here's some pictures in the 1970s during the oil embargo. Right, there is a long line of cars, and which is what motivated the industry to create more fuel efficient cars. Okay, so nothing else to say about emission standard. Let's talk about some pros and cons here. So pros, we can target a desired result. Right? Now with the example of the CAFE standard, right? We're interested in achieving a mile per gallon, but we can also set the standard for the emission directly. Right? It is put fair in quotes, right? Like I said, the same standard is applied across the industry for every firm. So we can argue that it is a fair system. Number three, all right, if you have an extremely harmful substance, right, you will want to use an emission standard to ban the substance completely. But overall, the main pro here, and this is the key, number four, right, it works well when the industry has homogeneous firms. Right? So meaning that each firm in the industry have similar technology, similar cost, right? Etc. And that way, is the cost of monitoring, enforcement, and understanding the standards is going to be very easy. However, if that's not the case, right, then emission standard might not be the best policy to reduce emission. Right? Lack of flexibility. Right? What if one firm can reduce emission much more cheaply? So, for example, let's go back to the example compare between Honda and GM. Right? So let's say that currently they're both meeting the standard. Well, now clearly Honda can further meet the standard or reduce their emission meaning improve their efficiency even more. But with an emission standard, once they met the standard, they have no more incentive to continue to reduce, right? And in the case of the car industry, right, we want every automaker to reduce emission as much as possible, right? So maybe one firm can reduce it cheaper than the other, right? One firm can reduce it cheaper than the other. Monitoring costs could be high, right? So in the case where we are looking at the standard, right? Looking at the efficiency standard, right? Volkswagen famously a couple years ago, right, have using software cheats, right, fooled the EPA for many years, right? It is most likely not cost efficient, not equal marginal, right? Again, that has to do with the fact that we are asking every firm in the industry to reduce or to reduce by the same amount, and maybe some companies, some firms can reduce more, right, at a cheaper amount, right? And maybe some companies, right, it is very costly for them to reduce, right? So such as, again, looking at GM and comparing GM and Honda. Okay. Number 4, we mentioned this already, right? Once the standard is met, there is no more incentive to continue reducing pollution. All right. So now to address the cons here, let's do a comparison. Right? So I'm going to continue looking at emission standard, but instead I'm going to look at a situation where there's only 2 firms in the industry. Okay, and now I'm going to look at this scenario, and first I'm going to apply a pollution standard approach, and then we'll see what the total cost is to reduce the pollution, and then we'll look at, well, what if we use a tradable permit? What if we use a market-based approach? Can we reduce the same amount of pollution, but at a lower cost? Okay, so now, again, assuming that there are only 2 firms in an industry, and also assume that we have figured out, right, the societal optimal amount of pollution to reduce is 40 tons. Okay, so here is the cost profile for the 2 firms. And right away we can see that firm 1, right, it is much cheaper for firm 1 to reduce emission than firm 2. Okay, now how do we read this graph here? So we've seen graphs like this before where we want to compare simultaneously 2 different quantities. So for firm 1, we will be reading the graph from left to right. So 0 is no reduction, and then as firm 1 reduces pollution, right, their marginal cost of pollution, marginal cost of reduction increases. Now for firm 2, right, we will look at from right to left. Okay, so firm 2, that we just flip the axis over, and starting at 0, and as they continue to reduce pollution, we'll go from 0 to right. And why do we want to plot both firms on the same graph? Well, because together they just need to reduce 40 tons. So let's say that firm 1 reduces 10 tons, then firm 2 will need to reduce 30 tons. Right? If firm 1 reduces 25 tons, firm 2 will have to reduce 15 tons. So graphing it together like this, we can see it right away what is the cost when we divvy up the amount of reduction for both of these firms. So with an emission standard, we will apply the same criteria for both firms, so which means that we will require each firm 1 to reduce 20 tons and firm 2 to also reduce 20 tons. Now to calculate the total cost of each firm at fulfilling their obligations, we have to look at the marginal cost of reduction at the 20th ton. So at the 20th ton, it costs firm 1 $200 to reduce that 1 ton. Now, careful, this is not the total cost. This is the marginal cost of the 20th ton. And for firm 2, right, we go from right to left. And for firm 2, it costs $600 to reduce the 20th ton. Okay, so now let's switch over to paper to do some numerical calculations. Okay, so I sketched it out. Right, so now from one, reduce reduce 20 tons total. The total cost for firm 1 is this triangle here. For firm 2, reduce from 20 tons, same amount, but for firm 2, the total cost for firm 2 is over there. So let's go ahead and calculate total cost for firm 1. Just is a triangle, so 1/2, 20 times 200. Okay, I'll set it up here for firm 2. 20 tons, but times 600. Okay, so here, right, we can do this math quickly here. That'll be $2,000. Total cost for firm 2, that will be $6,000. So under the emission standard, right, to reduce 40 tons, it costs the industry a total of $8,000. Okay, to reduce 40 tons. All right. Okay. So let's see if we use instead a pollution, or if we introduce a pollution permit system, right? That we can reduce the same amount of pollution, 40 tons, but at a lower cost to the industry.